everybody. So today is Monday, February 19th. And when is our exam? Wednesday. Yes. So Wednesday, I have a class before this. So if you want to come early to take the exams for free, and just come in the middle, and then I will give you the exam, and then you can find a seat to take it, or you can stay after class. But then it will be my office. Okay, we can go to my office to continue. And have you started the practice exam? Mm-hmm. Okay, so do you have any questions on the practice exam? So remind you today, I've helped with the Select 8 events, so I should be free after 11:40. So I will be in my office from 11:40 to 1:50, and then afternoon from 3:50 to 5. You have questions? Oh, so number 3, uh, let's see. So here you're doing U substitution, right? You let U be that, and then 7x, 7 over x dx, that's your du. So 1 over 7 du. Good. So then you plug in dx over x is 1 over 7 du. Then you don't have this. It's the 1 over x dx is equals to 1 over 7 du. And then this is u to the 5/4. Okay. Yeah. And then continue. So you integrate that. So it's after you integrate, don't put the integral sign. It's like after you take the derivative, you don't put the derivative sign again. Because you integrate it, right? So you add. Oh, so you're doing in the same step? Yeah. Do it in a separate step. Okay. Yeah. So after you integrate the u, so you can only have an integral when respect to u only. You don't want to see a mixture because you don't like to drink milk and all the juice together. Remember? Yes. Then after you integrate of the exponent. Good. Yes. So and also tomorrow, I usually in my office after 10, and I have class at 2. So hopefully 10 to 1:50, I will be in my office. And if you want to ask me questions in the evening, feel free to email me, and then we can go to the big blue button, and you can share your screen and you can ask me questions. Okay, everybody? And by the way, so your practice exam has a lot of problems. Your actual exams will have less problems than the practice exam. So I intend to make the practice exam harder and more practice problems. Yes. Okay, so let's see. Okay, so let me close that. So last time we talked about how to find the volume of a solid of revolution. So do you still remember that? We have a solid, right? We want to, our cucumber or potato, we want to cut it into slice. And our slice, either this method or washer method. If you cut it, you get this, then it's this method. Right, and then the area of a circle is pi r squared. Mm-hmm. And then if we get annulus, then the cross-section area of annulus is pi big R squared minus small r squared. Do you still remember that? And so keep this chapter 8 concept map with you, because it has like everything we learned in this chapter. Okay, so 8.2, the method. So how to find volume. First step, you draw the graph. Okay, thank you. So put some points and then connect them smoothly. And usually try to plot integer points, like square root. Square root of 0 is 0. Square root of 1 is 1. The square root of 2 is not integer. So don't plug in x as 2, right? Square root of 4 is 2. So try to plot integer points. Okay, and then connect them smoothly. And then after you find the region, sometimes you might have like the region is bounded by two curves. Then you need to find the intersection points. So there are two methods to find the intersection point. You either keep plotting points until you find it, or you solve the system of equations. Right, everybody? Mm-hmm. And uh, and then when we draw rectangle for our class, we only rotate about the x-axis. So our rectangle is always vertical rectangle. And then the width is the x. The height, which is the radius. It depends on the picture. So you draw the two endpoints of the rectangle and you rotate the rectangle about the x-axis and see what you get. If you get one circle, that is this method. Volume is sum of the volume of each slice. Each slice is like a cylinder. Thank you. So area of volume of a cylinder is area base times height. Do you remember, everybody? Or if you see annulus, that is sum of pi big R squared minus small r squared dx. So that is what we learned last time. And then we did example 1, right? We also did example 2. So example 1 was just a disk method, okay? So we plug in R. So this is R. We need to expand it in this case. And then the second example, we have two graphs, right? We need to find the intersection points. And we find the intersection point by plotting in the points and verify the points is actually on both of the graph. And then we draw the picture. You see there is a big R and small r. Thank you. Okay, and then we just set up the integral. Do not need to evaluate. And then exactly, we have those two functions. The first one, we plot 3 points, right? We get 0, 0, 1, 1, and 2, 0. So we connect them together. And then the second graph is x cubed. So we draw x cubed look like this. So today, let's continue. All right. So everybody see this rectangle and the two endpoints where we rotate about the x-axis, we get one big circle, that's big R. So big R, that is the vertical distance. So vertical distance is the, let me draw, okay. Here, we know given any function, the vertical distance is the y, the horizontal distance is the x, right? So the big R is the y of the upper curve. Y of the upper curve. Which function is the upper
curve? You said which function is the upper curve?
Yes.
That's the, is that the square root 2x?
Yes.
Squared?
Yeah, exactly. The square root of 2x minus x squared. And then the small r is the lower curve. What is the lower curve?
The lower curve is the other.
Yes.
X to the third.
X to the third. Exactly. Good. So now volume is sum pi times big R squared minus small r squared dx. Is everybody okay with the formula? Just by looking at the picture, imagine your cucumber, cut it into slices, then we get this formula. Right? Everybody? Mm-hmm. So this is integral. X goes from where to where? 0 to 1, right? 0 to 1. And then the pi, we can move the pi in front. Big R. Phi r is the square root 2x minus x squared, and we square it, right? Minus small r x cubed, we square it, dx.
Why do we square it again?
Oh, because it's area
Okay,
of the
yeah,
circle,
it's-
so pi r squared. So the solid is actually 3-dimensional. Yes. Remember last time I showed you the GeoGebra animation? You see the little rectangle moving, and then you see the solid it generates. Yes. So now we're gonna solve this integral. Ooh, what happened to the square and square root? They cancel. How nice. So we have 2x minus x squared. And what is x cubed squared? 5 or 6?
Um,
6. Yes. Dx. All right. Now we're gonna integrate. Okay, so at this step, we want to integrate. So after you integrate, don't put the integral sign because you don't want to integrate twice, right? So what's integral of 2x? X cubed 2x. The power increased by 1. Yeah, x squared. Yes, everybody?
Is it x squared over 2?
Yeah, so 2 times x squared over 2. Yes. How about the next term?
X squared.
X-
Or x cubed over 3.
Yes. The next term?
X to the 7th.
Yes. Good. Right, everybody? So, yes, we integrate that. And then we continue. So the 2 cancel. We plug in the 1. So 1 squared is 1. Minus, we plug in 1. So 1/3. Minus, we plug in 1. So 1/7. Right? What happens if we plug in 0?
Cancels out.
Yeah, they all become 0.
So then the final answer is 1 minus 1/3. Well,
Yes. And what is that? 1 minus 1/3 is 2/3, right? 3 and 7 common denominator is 21, right? So 3 times 7 is 21. 2 times 7 is 14, right? Minus 3,
yeah,
which is?
11.
Yeah, 11/21. I missed something. What is that? Yes, I need the pi. So this is our answer. So far, so good, everybody? So follow the steps. Draw the picture. Plus some integer points. And find the intersection.
And that's our final answer is the
Yes.
11 pi over 21.
Yes, this is the volume of the solid.
And that's the intersection of this. Right?
No, it's the whole volume.
Oh, the whole volume of
Yeah, of the
like
solid.
rotation.
Right.
Okay.
Exactly. Yes, everybody? Good. Now let's see example 4.
So could you use something like that like on Earth, like know the whole circumference of Earth and then cut it and then do that calculation?
Circumference is a yes. So you can use this to calculate the volume of a sphere.
Okay.
Yeah, exactly. All right. Let's see. Find the volume of the solid obtaining by rotating about the x-axis. The region enclosed by these 2 graphs. Okay, now it's your turn. So everybody draw the picture. Plus some integer points. The smallest x could be. plug in the integer.
Int.
So plug integer points. So if you know they're not integer, don't look at those.
Okay. Straight goes out.
Usually, when I ask you some problems, the intersection points are integer points. Yeah, plug integer points. You need to plug the square root. And you don't need the calculator. You don't, yes, because you're trying to plug integer points. It is integer, then skip that value. So don't plug in integer. Like here, what is the smallest x? One. Oh, if you plug in one, it gets square root of 4, which is 2. If x is minus 3, see, x is minus 3 is the, yeah, it's the smallest x. And minus 3, the y is, yeah, and can x be minus 2? Mm-hmm. See, we get integer points. Mm-hmm. All right. So let's check our answers. Okay. So this session is hard. Make sure you practice more. Okay, your homework and also your test book. So we have the plug in some x and y. What is the smallest x it could be? Yes. Then y is
0.
0. And then the next x value, you want integer? -2. Then you got 1. And next integer? 1. Square root of 1 plus 3 is 2. Okay, so let's look at those 3 points. So 1, 2, 3, and it's 0. -2 is 1. 1, we got 2 right here. So we connect them. right? So maybe the graph is not like okay, like that. Okay, so this is the first graph. A second graph, let's use a different color, okay? Do you see second graph, the degree of x is 1? So it's a linear function. It's a line. So we only need 2 points can fix a line. Okay, could you tell me some x values you want to plug in? 3. If we plug in 3, what do we get? 3. Okay. Other points? 1. Then we get 2. Oh, you see 1, 2. We actually find the intersection point. And actually, do you see if we plug in -3, what happened? 0. How nice! So we find those 2 intersection points. We find those 2 intersection points. And this is the region. We want to rotate about the x-axis. That's x-axis. That's y-axis. Okay, we want to rotate. So we draw our little rectangle like this. Yes? We color it vertically. Yeah, it's a tiny rectangle. And you want to draw what happens if you rotate about the x-axis. Okay, here we get one circle. Here we get a bigger circle. So we have big R and small r. Yes, everybody? So big R, what is big R? That's the upper curve. Y upper. Which curve is Y upper? Yes, square root of x plus 3. And the small r is y lower. Who is y lower? Yeah, the line. X plus 3 divided by 2. So draw the picture, and then the picture will tell us which one is big R, which one is small r. Okay? And then the formula. V is sum pi big R squared minus small r squared dx. Everybody okay with the formula? Sum of the volume of each side. So area base times height. Okay, integral. Pi, we can move it outside. Look at the x. X goes from where to where? Yes, very good. -3 to 1. Big R. Big R is the square root of x plus 3 square. Right, everybody? That's the big R minus, what's the small r? The x plus 3 divided by 2. And then this whole thing square. Yes, everybody? Yeah, we can cancel the square root and the square. We get x plus 3 minus, what is 2 squared? 4, yes. So this is like 1/4 times x plus 3 squared. Yeah? What is x plus 3 squared? Can we also expand it? A plus b squared is a squared plus, yeah, 2ab plus b squared. So x squared plus 6x plus 9. Yes. We expand it. Okay. Do you like to work with fraction? I don't like to work with fraction. So what I do is I'm gonna I can either separate them and then work on this and this respectively. Or you can multiply this by 4 and divide it by 4. Then you can factor out the 1 over 4 and put it outside of the integral. Which way do you prefer? Do you like to multiply by 4 and divide it by 4 and then you can factor out the 1 over 4 in front? Or do you want to work on this part and this part separately? So which way do you prefer?
I think the second one.
Separate them?
Yeah, that sounds
okay.
better.
Yes, sure, we can do that. So it's pi minus 3 to 1 x plus 3 dx, separate them. And then minus, now we can still have the pi, right? Now it's over 4, integral from negative 3 to 1. Now we have x squared plus 6x plus 9 dx. Is everybody okay with that? We separate them. And then we can move the 1 over 4 in front of the integral. Let's see. So integral, what's integral of x?
X squared over 2.
Yes. X squared over 2. What's integral of 3? 3x. Evaluate from minus 3 to 1. And then minus pi over 4. What's integral of x squared?
X cubed.
What's integral of 6x? Yeah, 3x squared. Is everybody okay with that? What's integral of 9? 9x, yes. Plus 9x. We evaluate from minus 3 to 1. Good. So let's plug in. The first one. We plug in 1. So we get... What do we get if we plug in 1?
1/2.
Yes. Minus, we plug in 3, negative 3. What's negative 3 squared? 9. So 9 over 2. And then negative 3 times 3 is negative 9. Yes, that's the first part. Minus pi over 4 of the second part. Second part, we plug in x is 1. What do you get? 1/3 plus 3, right? Plus 9 minus, we plug in negative 3. Okay, let's see when we plug in negative 3. What happens? Negative 3 cubed is 27. Negative 27. But divided by 3, negative 9. Yes. Negative 9. And then negative 3 squared. 9. 3 times 9? 27. And then 9 times negative 3? Negative 27. So when you work with negative numbers, be careful with the negative sign. So 27 and negative 27 cancel. Let's see. So now you can put this in your calculator. Let's see. What do you get? I got 43 pi over 6. I don't plug in the pi. I just plug in these fractions, It gave me 43 over 6. You have the same thing. So we use pi. So in the exam, it is a nice number. I would say this is a nice number. It's just a fraction times pi, so you can leave your answer like this. But it is more complicated, like with exponential function there. Then you can give me a decimal. Mm-hmm. Any questions about finding the volume of a solid rotating about the x-axis? Everybody okay with the steps? What is the first step? What do you do? Plug in integer points and draw the graph, right? And how about your second step? You draw the little rectangle, right? And you rotate about the axis and see what happens. You get one circle, that's the disk method. Two circle, that's the washer method. Yes, everybody? Mm-hmm. Okay, then you can set up the integral and then evaluate the integral and then plug in the numbers. Okay, so that is the volume. That's the first applications. And then the second applications of integrals is finding the average value. Okay, so I love to use analogy. So average value. Let me tell you a story. So it's in the summer. Okay, it's very hot, and you go to a swimming pool. Okay, so when nobody's inside the swimming pool and the water is very flat, right? And you can see the purple area is the let's talk about the 2D. Okay, the purple area represents the water in the pool. Okay, the cross section. And then when you jump into the water, let's imagine your volume compared to the water volume is, you can ignore it, okay? So when you jump into the water, you can see the water level change. Let's say this is a curve. And do you see the blue area equals to the purple area? Assuming you're so tiny, we don't count your area, right? So the water area is the same. And then what is the purple area? So we have the function from A to B. Do you see the purple area is a rectangle? So for rectangle, it's length times width. Okay? And what is the length? Do you see the difference between 2 points is B minus A? And then that's the length, and the width is the height H. Okay? So that is the purple area. Now how about the blue area? For the blue area, that my water level is my function f. The blue area is exactly the area under the curve from A to B. So that is the definite integral of f from A to B. Okay, everybody? So if I want to find the average value, like the highest average value, when my water settles down, what is the height? That is the average value. So then you use the blue area divided by B minus A. Okay, everybody? So this is the formula of the average value. And when you do, imagine the story, you jump into the pool. Okay? So the purple area, the rectangle, equals to the blue area. So the average value is the definite integral of f from A to B over B minus A. Okay? Yes. So in the exam, I won't give you any formula sheets. So I hope you can review this concept maps and then find them and write down the formula on your own. Okay? Yes, we understand that. And so imagine this story, then you can write down the formula. Okay, so find the average value of the functions on the interval -2 to 2. So let's draw a picture. Okay, so this is the x, this is the y, and we want to draw the graph, right? -2. If you plug in x is -2, what happens? Your y is 0. Yes. If you plug in x is 0, what happens? 2. Oh, yes. If you plug in x as 2, what happened? 0. Oh, you see, everybody? We get a graph like this. Okay? So the average value is the area. Now, not volume, okay? We're not talking about the volume of a solid, just the area, okay? Over the difference of this interval. So let's see. Step 1. Let's find the area. Okay. And if you can remember in session 7.3, when we talk about the definite integral, if you see square root of a number minus x squared, it's actually a circle. Do you still have the chapter 7 concept map? Yes. So, which is right here. Okay. Yeah, method 2. If the function is a line or circle, then you use geometry to find the area of the function, under the function. Okay, and what is a circle? Okay, so standard form of a circle is here. Okay, yeah, it's here. X minus h squared plus y minus k squared equals r squared. With the center is h comma k. Radius is r. So in this case, you see y equals square root of 4 minus x squared. If we want to change it to the standard form of a circle, we will square both sides. We get y squared is 4 minus x squared. Yes, everybody? And then we move the x squared to the left. We get x squared plus y squared equals 4. This is the standard form of the circle. Now, see, the standard form of the circle. You compare. My h is like 0. My k is like 0 because you only have x squared. You don't have x minus a number squared. So therefore, the center is the origin. What is your radius? Your radius is 2. Very good. So you actually get a circle. But the square root, the positive square root is just the upper circle. If you want the lower circle, it should be negative square roots. Yes, everybody? So this region is, integral from minus 2 to 2 square root of 4 minus x squared. By the way, we're not able to integrate because this is not one of the formula we learned. We only learned 3 times. X to the n, right? Is this x to the n?
No.
No. Second time, exponential function, e to the ax. Is it like that? No. And then the third time is 1 over x. Is it like 1 over x? No. Even though you want to use the u substitution, if you let u be this, du will be negative 2x dx. So you need an x here. Without x here, you cannot do u substitution. So this integral, we're not able to integrate with the knowledge we learned so far.
You can't half power it? You can't put it to half power instead?
What do you mean by half power?
Yeah, like instead of turn the square root into half power and then integrate.
It's still, it is u substitution. You need an x here to do that. But because here we don't have the x, we cannot use u substitution. So we're not able to integrate with the knowledge we learned so far. Okay, but if you draw it, you see it's a circle. So we can use geometry. Is half of a circle. So 1/2 pi r squared, and our r is 2. Yes, everybody? That's why 2 and the square cancel. We get 2 pi. The area is 2 pi. Is that okay, everybody? Mm-hmm. After you find the area, now you can find the average value. So average value is the area over the length. What's the length? What's the difference between those 2 points? Yes. B, in this case, A is -2, B is 2. So 2 minus -2 is 4. So what is your final answer? Pi over 2. Very good. So this is example 1. Find the average value of this function. And yes, either for circle or if you have a line, you can do geometry. Okay? This is example 1. Now you do example 2. That one, find the area first. These. You need to use the integration by parts. Do you still remember the integration by part formula? Integral u dv equals u v minus integral v du. Mhm. So set up the area, find the area. Yes. I strongly recommend you to bring your constant map of u. Yes, this is a chapter 8. Oh, yeah, yes. And you have the top and the bottom. Yeah, yes. The integration by part is there. Yeah, you might not get integer points. So it's okay. So just set up the integral. So the integral is the x goes from here to here, and that's the function. Remember, if you see power function times exponential function, you let u be the power function, and you let x be, sorry, v. Okay, where is it? Okay, here. Integration by parts. If you see power function times exponential function, let u be the power function. dv is the exponential function. If you see natural log times power function, you let u be the natural log, and then the remaining is the dv. You don't need to draw this because you don't get integer. It's natural. If you really want to draw it, you can sketch. So if you plug in 1, do you know ln of 1 is 0? So it's 4 times ln 1 is 0. If you plug in 3, it would be a positive number. Some positive number. So when it's 1 is 0. When it's 3 is some positive number like that. So the picture looks like that. And you want to find this area. Okay. What's the area? X is from 1 to 3 and 4. Okay, this is x to the what power? What? What power? 5 power. Very good. Times natural log of x dx. Yes. So you can move the 4 outside and let that to be, sorry, this be u, and then the remaining be dx. Okay, so try this problem at home. And then next Wednesday, we're gonna have exam. But then Friday, we will go over this problem. Okay, so try this problem at home. Any questions about today's class? Oh, good. Okay. So yes, work on your practice exam. Ask me questions, and our exam is on Wednesday. Have a nice day. Yeah, do your homework. If you have questions about your homework, please. Huh? Oh yes. You have to take the next. Yes. Oh, that's why you're studying. Okay, good. Do you have any questions on that?